Okay, welcome. I had assigned the law of cosines assignment on Friday. So it was assignment 3 in your package. I've heard from a couple of students. I apologize for being a bit late. Hard time getting going online, getting a live stream. So hopefully everything's going to work well. I assigned assignment 3 in the booklet. So I thought that I would, I know that a few people have been having a hard time keeping up. So I thought today I would just go through assignment 3 and do all the questions of assignment 3. I know some of you have already finished the assignment, so that's wonderful. But just for the benefit of people who have been struggling a little bit and keeping jobs even perhaps, that I would go through the questions for assignment 3 to let people know that that I hear the problems that you're having keeping up. And for those who have already finished assignment 3, then I guess you have a free class, right? And you could try and go on to assignment 4. Tomorrow, I'm going to talk about assignment 4, which is applications. And that means word problems. But I'm going to slow it down. Partly it's a Monday. It's the beginning of a new week. I also got a comment that they wanted the camera a little closer to the screen. So I'm going to pay attention to that today too. So what I'm going to do is I'm just going to go through the questions for assignment 3. I'm going to go through them one by one. Again, if you've already completed the assignment and you have no questions, then you have a free hour and you can go and excuse me, you can work on some other homework that you may have. I'm sure you've got other questions or other work that you want to get done. So please let me know if you have questions about assignment 3. That's what I'm going to work through today. The law of cosines, right? So law of cosines. And what we learned last week was that the law of cosines, there are only 2 times. Hi, Cynthia, Ruthiana. The law of cosines has 2 cases, right? We've got side angles, side triangles, and side, side, side. When we have a side, 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 we're solving for an angle. And when we have side angle, side, we're solving for a side. Now, the formulas are given to you, right? So I would suggest you have the formulas printed. And again, the formulas are, so solving for a side, solve for a side. The formula is a squared equals b squared plus c squared minus 2 times b times c times cos of a. And then solving for an angle. The formula is cos of angle A, right, equals b squared plus c squared. They start out the same, minus a squared. This a squared flips over. These guys change places, actually. All divided by 2 times bc. Now, if you remember that formula sheet that I gave you, the formula sheet that I gave you a long time ago when the class started. Hi, Tiana. Nice to see you. It has these, on the flip side, it's got the law of sines and the law of cosines. And you can see the 2 versions are given to you there. So again, these are, if we were in a regular, on your own sheet, but because they're given to you. So I would always suggest that you have your formulas in front of you. So I'm going to leave my formulas in front of me. Now you're not going to really, you might not see this all the time, but I'm going to leave them right in front of me, like right up here. So I'm just going to move mine up here and I'm going to just work through these again. Okay. So what I would do is, now I know that all of these questions are law of cosine. So it's kind of easy in that way. And no, Cynthia, you don't have to email me the law of science assignment. I did post the answers so you can check your own, but if you have any questions on that one, please let me know today. So I first look at this question, number 1A, and I know this is a law of cosines question. So in one way, it makes it a little easier. So I see this as x, so this must be a side angle side. And sure enough, I have the side, a side, the angle in the middle, and another side, right? So these two are my B's and C's. So it doesn't matter. Let me call this angle B, and let me call this angle C. Or sorry, side C. Side B, side C, and this, of course, is angle A. Okay? So that means I'm solving for x, which I guess I could call A, right? Because angle A and side A are partners. Therefore, I'm going to use the law of cosines that solves for a side, right? Here, this one, we're solving for a side. X means we're solving for a side, so it's b squared plus c squared, whoops. B squared plus c squared minus 2 times b times c times cos of A. Now it's just a matter of substituting all my values into the proper formula, right? So a squared equals b squared plus c squared minus 2 times b times c times cos of, what I'm going to do is I'm punching everything in the calculator. Whoops. 30 squared plus 51 squared minus 2 times 30 times 51 times cos of 85. And I get this big answer, right? Now, as I said last week, ... I'm putting the ... That's indicating that I'm just going to leave it in my calculator. Whoops. I'm going to leave it in my calculator because I've not finished the question yet, right? I want to find A, so I have to square root everything. So what I do is in my calculator, I can just leave the answer in and I just have to press the square root button and equals, and I get 56.87. Now, the only thing that I have to change, sorry about that. The only thing I have to change is they told me to solve for x, not a. So that means that x equals 56.87 centimeters. Okay? So that's the question. Now part B is the same thing, right? Now because I've done a few of these, I know these are my two sides, right? This is my BC. So what I can do is, and instead of maybe calling him A, I know he's going to be X. So I'm going to say that X squared equals B squared plus C squared minus 2 times B times C times cos of 53. I'm starting with X and starting with the X, not A, because I know I'm solving for X anyway. So instead of using A all the time, I'm just going to use X. Okay, and everything else gets put. I'm not using B's or C's in my work because I'm just putting the B's and C's in their appropriate place. So once again, I'm going to get a big answer. So 6 squared plus 7 squared minus 2 times 6 times 7 times cos 53. And I get a big, huge answer. And again, this is my way of showing you. I'm just leaving that in the calculator, right? So then I square root this whole thing, right, to figure out what X is. Oops. So X equals square root 5.87 if I round properly, right? 5.87 meters. So once you do a couple of these, you can see that like I don't record the whole formula out all the time anymore. I'm just substituting the two sides I'm given go here. They go here and here. And then they get multiplied by the angle at the end. So this is all the info I was given, right? The two sides and the angle. So once you do a few of these, they get pretty familiar, I guess. Okay, once again, part C is still solving for so we have 74, 74, and 30 degrees, right? So for part C, x squared will equal 74 squared plus 74 squared minus 2 times 74 times 74 times cos of 30 degrees. Okay, see how simple that starts to become? The sides, and the angle. It's your calculator that does all the heavy work for these questions, right? 74 squared plus 74 squared minus 2 times 74 times 74 times cos 30 equals 1467.289 ... Square root the final answer, and I get x equals 38.31, and I can't remember if it was feet. Okay. Okay, so now let's see what the next question holds, and I'll post these on the blog, of course. Let's see what the next question is. Question D, I wonder if I can move this over a little bit. Okay, so he says, I've got a triangle with 3 sides and I'm solving for the angle, right? So what I do is, actually maybe I'll do this one on here. This is the angle I'm solving for. So if this is the angle, this is my side A, right? That's the only one you really have to identify. These two are B and C, and the order absolutely doesn't matter. So I'll call this one B, this one C. The only one that matters is that you identify which side is across from the theta, because that's the side that has to be minused. So I'm using this formula, cos of A equals B squared plus C squared minus A squared. And that's why it's really important to identify A, because it's the one that gets minused, all divided by 2 times B times C. All right, so I'm going to put this in the proper format. Cos of, instead of A, I'm calling it theta, equals, so this is the step. When I move from here to here, this is when I substitute all my given info in, right? I was given 28, 22, 19, and theta. So that's why I'm substituting everything in that way. That's why I substituted the theta in for A. All right, so B squared plus C squared minus A squared all over 2 times B times C. Okay, B times C get repeated. Now, for these questions, plus 22 squared minus 19 squared equals, I have 907 on the top, 2 times 28 times 22 equals 1232 on the bottom, okay? So, in my calculator then, I'm going to get a decimal answer, right? So I'm going to get cos of theta equals 907 divided by 1232. Now these guys look weird. Anytime you're solving for an angle, it looks weird at the beginning. Okay, so I get a decimal answer. Now just like we did for law of sines, if you look at this, I have cos of theta equals this funny decimal answer, but I want just theta, right? Well, how do I do that? I have to get rid of the cos. Once again, I leave my answer in the calculator. That's why I put all those ... dots. And the get rid of cos button is right above cos. So I just go shift cos equals 42.51 degrees. Or sorry, 59 degrees. Now, once again, you have to kind of learn your calculator. Most calculators work like mine does. But if it doesn't, if yours doesn't, you're going to have to figure your calculator out. And if you keep struggling with your calculator, you can just email me, or you can come on the Google Meet. Remember, every day at 10 o'clock, I have a resource period. So you can just click onto the resource period and visit me virtually if you want. And maybe I can help you figure out your calculator that way too, if you struggle with it. Usually I can figure out calculator problems though, but I think most of your calculus would work like mine. Now I can see that all of these are the same, right? They're solving for theta. So I'm going to use this same formula that I have up here. The only thing that really matters to me, or I think, that is if you identify who A is. Okay? If you identify who A is, it doesn't matter who B and C are. So this is B and C. So cos of theta equals the B squared plus C squared minus A squared, all over 2 times B times C. Now, just like I did the last question, so 17 squared plus 20 squared minus 12 squared. I have a 545 on top, and on bottom, I have a 680. When I do my division, that's when I get that funny decimal answer, right? So be prepared. You're going to get that funny decimal answer first. And I get 0.8014 dot, 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 dot. And now I want to just leave that. Theta equals 36.73 degrees. So hopefully you can see the repetitiveness, right, of these types of questions. Sorry, just a minute. Again, I look at this, here's my theta, there's my A. So these guys have to be B and C. So cos of theta equals B squared plus C squared minus A squared all over 2 times B times C. Okay. This time I get a negative 263 on top. That's okay. Don't worry about it. Sometimes we get negatives. Divided by 598. But remember, you have to put the negative sign in your calculator, right? So last week we talked about it. Most negative signs on calculators come, there's a plus minus sign somewhere on your calculator. So that's the one that you want to press. So you get the negative button. Negative 263 divided by 598. And that gives me a negative decimal number. Once again, that's okay. That number stays in your calculator. Sorry about that. And now I'm going to shift cos. And my answer ends up being a really big angle measure, right? 116.09 degrees. Okay. And the last question, again, hopefully this is becoming really straightforward now. So here's A. So this will be B, this will be C. So cos theta equals 12 squared plus 10 squared minus 21 squared. Got negative 197 over 240. So cos theta equals, again, I'm going to have a negative decimal number, right? A preliminary, right? Don't worry about that, dot, 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 dot. Now I'm going to go my shift cos. And I get 145.17 degrees. So that was assignment 3. Hopefully, you got mostly correct answers. And really what this becomes is an exercise in using your calculator, right? Making sure you know how to use your calculator properly and ensuring that it's a good tool for you. Because really in math, at this level in math, your calculator is a very, very important part of your progress, right? In essential math, we know that there are real life application questions. So quite often they involve large numbers, and technical information like trigonometry requires a really good scientific calculator. So if you're having any problems at all with your calculator, please let me know through email or pop onto the Google Meet tomorrow or onto the chat here. That concludes, if you kind of look at the outline of this unit, then we're heading to the end of another unit, right? So we've done just an intro to triangle, done sine and cos, and now we're doing applications. And applications are word problems. I will introduce this to you today, but this is a very lengthy intro. It starts off with a couple of supplementary pieces of info, but there are 8 examples in total. So I'm not going to get through all 8 examples today. I'm going to just maybe do while you do before tomorrow's class. Sorry, I just have to get this. Sorry about that, guys. Just want to get this camera lined up a bit. There. So lesson 4, applications, and that means word problems. So we can use the law of sines and cosines to solve problems based on real life situations, which is why we're learning this math. Before we start, we need to define 2 concepts that will help with some application questions: complementary angles and supplementary angles. So those are 2 important words to remember in math. They always, they're part of trigonometry. So the words complementary and supplementary. Complementary angles add up to 90 degrees, okay? So complementary angles add up to 90 degrees. So if you know the size of one, of course the angles have to be less than 90 if they both add up to 90. Determine the size of the angle theta in each of the diagrams shown below. Remember, if we have the box here, the box is the symbol, it's the universal symbol for 90 degrees. So if they tell me that this little angle here is 55 degrees, then theta, this is sort of the same technique we used in the be equal then to 90 take away 55, right? It has to be equal to 35 degrees. So theta must equal whatever 90 is, take away 55. And that will equal 35 degrees. So when you're given the little box, it's a corner, right? And the corner is 90 degrees. Therefore, 90 take away the 55. The theta has to be 78. Okay, this theta has to be, here's my box, 90 take away 78. And that should give me 12 degrees, right? So theta equals 12 degrees. So it's expected that you remember what the box means, right? The box means 90 degrees. Now that will come into play in some of these word problems, I think, later on, which is why they're stressing this. Now, supplementary angles, if you think about it, but just think about this for a sec. Just take my other paper here. If I have like a perfect corner here and another perfect corner here, well, I know this is 90 degrees and 90 degrees. Therefore, the 2 perfect corners, a straight line from here all the way to here again is 180 degrees. Okay. Now, 180 degrees has special significance for us. It's also the 3 angles of any triangle equal 180, but a straight line is said to be a straight angle, and it's an angle of 180 degrees. And that's what the word supplement means. Complementaries add up to 90, supplementaries add up to 180. Determine the size of the angle located at theta in each of the diagrams below. So we have a nice straight line, right? If this is 120, then theta has to be equal to the whole line is 180. Excuse me. 180 take away 122 leaves me with 58. So 58 degrees is the measure of angle theta. Here, same thing. Theta will be equal to 180 take away 19. And that's going to give me 161 degrees. So remember that if you're ever given a real life application question where two angles make up like a whole line, you know that the leftover has to be whatever's left over from 180. And if we're talking about a corner, the measure of the whole corner angle is 90 degrees. This type of supplementary angle info could become important when things are like perhaps lying on the ground somewhere. But let's see how these could help us later on. But don't forget page 18, the words complementary and supplementary. All right, let's try a couple of these examples before we call it a day. Example 3. Tarek sees an airplane flying away from him at an angle of 23 degrees. Hillary is 8.2 kilometers away from Tarek. She sees the airplane flying towards her at an angle of 8 degrees. Calculate the distance between Hillary and the plane. So they've got it nicely outlined for you. The picture's here. Here's Tarek. When he looks up at the sky, his eyes make an angle of 23 degrees, right? That's what that means. You can see that the shape, if I drew lines between Tarek, Hillary in the plane, and Tarek in the plane, this whole situation can be described as being in triangular formation, right? Tarek, Hillary, and the plane are in a triangular formation towards each other. Calculate the distance between Hillary and the plane. So they're asking me for this. So I have to ask myself, is this a law of sines or law of cosines question? A couple ways you can think about it. As long as I have some kind of partnership, it's law of sines, or it's only law of cosines if it's side, 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 if they gave me all three sides, which they don't, or if they gave me two sides and an angle. So it's not law of cosines, so it must be law of sines. So let's see, for law of sines, I need a complete partnership, which I don't have a complete partnership here. I don't have a complete partnership here, so that must mean I have a complete partnership here. And I guess I do, right? Because I can easily find this angle. This angle will be 180 take away 23, take away 8. So that 180 rule we've used a lot of. So this ends up being 149 degrees, right? So I have 149 degrees. And sure enough, I have my partnership. It took me a minute to get there. That means that 8.2 partners with sine of 141. And then these guys would be partners. They're not complete though, because I don't know what x is. So x partners with sine of 23. So once again, I'm going to use my cross multiply technique that I learned with law of sines. I multiply and I divide. So 8.2 times sine of 23 divided by sine of 141, and that should give me my length of x. And I get 5.09 kilometers. And that's how far Hillary is from the plane. Okay. So for this one, it's going to be a little harder. Now you're given the picture, but for this assignment, you don't know if it's sine or cos, and that's the tricky thing is, right? You have to decide if it's a law of sines or a law of cosines question. So let's try the next one. we'll try this one more and then I'll stop for the day. A triangular solar farm in Colorado has sides measuring 23 meters, 47 meters, 34 meters. Determine the size of the smallest angle. Note that the smallest angle is always opposite the smallest side. I think we learned that before, but that's worth noting too. So this is the smallest side, so its partner is the smallest angle. So I can clearly see this is law of cosines, right? Law of cosines only has two types of triangles that you use it in. If you're given all three sides and no angles is one of them, right? So this is law of cosines. And because we're given side information. So remember, if this is the angle that I'm trying to find, this side is side A. Okay, so these two must be B's and C's. And again, it doesn't matter who I call B and who I call C, so I'll just put the BC here. So therefore, cos of the angle I'm looking for equals B squared plus C squared minus A squared, right? That's the important one. All over 2 times B times C. So cos of theta equals, okay, so I have 34 squared plus 47 squared minus 23 squared. The top is going to be 2836. And the bottom is 3196. So I get, once again, these are just exactly like those questions we just finished up doing in assignment 3. I'm going to find a decimal answer. And I get 0.8873 ... And now I'm going to shift cos. And I'm going to get 27.46 degrees. Okay, so these are going to be tougher than the assignments because the previous assignments told you it was a law of sines or law of cosines. These don't. You're going to have to figure out for yourself which is which. So we've got lots of examples to finish doing. And this is a very long assignment. So I think it's going to take us a couple of days. And I might end up having one of the days just be a work class. And I think I might just either keep the chat open or also maybe have a Google Meet and just have a drop-in class if you have questions on it. Okay, so I might try that for maybe Wednesday or Thursday. We'll see how this goes. All right, I'm going to leave it there for today. What you could try and do if you want, I mean, you can try and work through the rest of the examples on your own. They don't have answers given to you, right? So it's quite a challenge. So you could try to work through the examples if you want. There's no homework except to catch up on what you may have been missing. Okay. Okay, I'll just stay on the line for a minute or so. Just let me know if there's any more questions that you might have. And if not, I will, I guess, stop the stream for today and I will be in touch with you tomorrow.